Hello buddies, this is Molly from Mona's CAD Solution. Today we are going to learn a topic regarding dimensionless numbers, and it can be remembered easily by remembering a trick, that is Mahamantra. I already explained it in the video and now I am going through it because I told that I will upload some problems and these slides have some problems, so please go through it and practice it. You will get. So dimensionless number, these are the numbers used in dimensional analysis for finding various values of standard notation. They play a vital role in making equations parametrically, and they are used both subjective and competitive wise. And now here is the Mahamantra, that is RFEWM VGPSE. RFEWM VGPSE, or RFEWM VGPSE, or is a Reynolds number, which is the ratio of inertia force to the viscous force. F is a Ford number, which is the ratio of square root of inertia force to the gravity force. E is a Euler number, which is the square root of inertia force to the pressure force. Double G is the Weber number, which is the square root of inertia force to the surface tension force. M is the Mach number, which is the square root of inertia force to the elastic force. And now, in the previous video, I didn't give any formulas or problems. So now I am giving the formulas for everything. For a Reynolds number, I already said it is a ratio of inertia force to the viscous force, and the inertia force is the product of mass into acceleration. Mass, we can write it as rho into volume, because density is the mass by volume and acceleration is velocity by time. Rho into volume by time into velocity, and volume by time we can write it as area into velocity. So finally we get inertia force as rho AV square. And now going to the viscous force. Viscous force is the product of shear stress into area. Shear stress we can write is mu du by dy into A. Tau equal to mu du by dy, and we can write du by dy as v by l, mu v by l A. So Reynolds number is F by Fv. We can hear the transitions getting cancellations. We get rho v L by mu, and we know mu by rho is the kinematic viscosity, as mu is the dynamic viscosity. Dynamic viscosity by density is the kinematic viscosity. So we can write Reynolds number as VL by mu. Coming to Ford number, it is square root of ratio of inertia force to the gravity force. Ford number is square root of inertia force to the gravity force, I already said. So what is the gravity force? Force due to gravity. That is the mass into acceleration due to gravity. Rho into volume into Z, rho ZV, rho. We can write volume as L cube and area as L square. Writing it here, rho L square into L, rho A L G. And finally see the transitions. Finally we get a Ford number as V by root LC and getting cancellations. Now coming to Euler's number. Euler's number is the square root of inertia force of flowing fluid to the pressure force. Euler number is nothing but P by rho, and you can see the transitions. P, where P is the pressure force into area. Now the next number is Weber's number. Weber's number is the ratio of square root of inertia force to the surface tension. And what is surface tension force? Surface tension in per unit length into length, that is sigma into L. We are writing here as square root of Fi by F is getting cancellations. We see finally Weber number as V by root sigma by del L. Coming to the next number, that is a Mach number. Mach number is the square root of ratio of inertia force to the elastic force. So M equal to root Fi by Fe, where elastic force is the product of elastic stress into area, that is KL square. M is nothing but ratio of square root of ratio of this 2, and we get finally V by root of K by rho. What is root K by rho? It's a velocity of sound in fluid. Remember it. So we can write root K by rho as C, that is the velocity of sound in fluid, and M equal to V by C finally. Now see the question. It is observed that in a flow that the total pressure, inertia and gravity forces are important. Then the similarity requires. Short number and Euler number absolutely, because writing RFEWM VGPSE, all the forces have inertial forces same, pressure and gravity forces exist in Rod number and Euler number. And next one, Euler number is defined as a ratio of inertial force to the absolutely the pressure force. Option C is your answer. The next question, Reynolds number is the ratio of inertial force to viscous force. Option D is your answer here. And I wrote RFEWM VGPSE like this. You have to write in the exam and find easily what a number relates to with force. Coming to the next question, it's on the operations of the numbers. So capillary waves in channel is Weber number. Testing of aerofoils is turbulent Mach number. Flow around bridge piers is 4 number. Turbulent flow through pipes is it's Reynolds number. Your answer is D, so please check it out. It's an operations of numbers, and if possible I will also make a video on this. The next question is regarding the formulas which we discussed in an early slide. So you can get it, you write the formulas in the paper and you just match it, and the answer is B. I'm not going to explain it. So the next question, see, you have to remember all the formulas because it's so important. You may get, but you just need to remember that's Mahamantra. And the next question is the similarity one that we have discussed in the early one. It's observed in a flow problem that pressure, inertia and gravity forces are important. Then similarity requires pressure and gravity forces have 11 4 number. Option C. In the next question you can match it and you can enjoy. So I'm not going to discuss. I will give you answer, but please go and enjoy. And the next question is also same thing, but I want to explain that compressibility force is for Mach number and the remaining are same. And option A for 3, B2, C5 and D4. That's all. You can write RFEWM VGPSE, then you will get it very easily. So this is answer for what I didn't give. So thank you so much. Please like, share and subscribe. Yours Mauli from Monoscare Solution. Hello buddies,